Okay. So, hello everyone. So my name is Marc-Olivier Buob. I work at Nokia Bell Labs, and today I will talk about the operator and the functools Python modules with a S. The outline of the presentation is the following. So first we will recall some basics about Python that are required to understand the two following parts. So during the introduction part, we will talk about the notions of lambda, callback, functors, decorators, and context managers. So if it's new for you, no problem. I hope it will be clear. Then we will talk about functools that provides convenient utility on top of those notions. And if the times permits, we will talk a little bit about the operator module. Okay, so let's go. So introduction, what is a lambda function? So this is just a way to write a function in an inline way. So in this example, you have the function f that takes two parameters, x and y, and that returns some value. You can rewrite this function as a lambda function, like g. And as you can see, so the parameter will appear after the lambda keyword. And then after the semicolon, you will have the value that you want to return. So you can observe that there is no return because there is only one operation in the lambda function, and the result of this operation is returned. So this is the lambda keyword. So now a callback. So why lambda are useful? This is because often we can use them as callback. So what is a callback? This is a function that you pass as a parameter of another function. So for example, by default, if you call the sorted function in Python, it sorts the values in the ascending order, as in the first example. But now assume that you want order an iterable using another order. So for example, assume that you have those tuples, 1b, 3a, 5c, 6e, 2f, and now you want to order those tuples according to the letter. So this is not the default behavior because the natural order for a tuple is first ordering according to the first element of the tuple, then the second element, then the third element according to a lexicographic order. So here we want to use another order, and that's why we will require a callback. And fortunately, sorted expose the possibility to pass this order. So this is not exactly the order, but we'll talk a little bit about this later. This is something that is orderable. So, for example, here, the characters, or rather the strings, are orderable. We want to order according to the ascending order of the strings. So if we extract the letter of each tuple, we are happy. So here, this is exactly what we will do. As you can see in the last snippet, we will extract from the tuple the first element of the here, so this is by number if we take 0, but if we want to sort by letter, we will change the 0 by a 1. Okay, so like here. Okay, so now what is a functor? So as you can see here, when you use a callback, there is no notion of constructor. There is a function. You will pass the value, and that's all. But sometimes your function depends, your order depends on some parameter that you want to define before. So let's take an example. So assume that, so in math, it's written like this. For example, you have the function fab that takes as parameter x and y, but it is parameterized according to a and b. And so in Python, a functor enables this kind of writing. So basically, what you will write, so sorry in the slide because it's swapped. So a and b are the parameters of not call init, and x and y are the parameter of call. So sorry, it's swapped on the slide. So let's take an example. So we will reuse the previous example where we want to sort either according to the first element of the tuple or the second element of the tuple. So in my item getter, I can state whether I want to take the element 0 or 1 of the tuple. So this is what I call index in the init constructor. I will save this index in a parameter of the class. And then when I will call my callback, which results from this constructor, then it will enter into the call method. So here, as you can see, so here we have I equal 0. So we are at the first loop, we are picking the element 0. It gives me something that behaves like a function, but which is parameterized according to the index 0. And here I will sort according to the item 0. So this is what we can see here. Then at the next iteration, I will be equal to 1. So here I will get 1, 1. And so when I will sort my tuples, here I will sort according to tup bracket 1. So I hope it's clear. It's just to show you that sometimes the way you want to define your order is defined by a parameter, and here this parameter is I. Okay. So what is a callable? So this is the generic name to design a function, a lambda function, or a functor. So it gathers all those kinds of things. What is interesting? So as you have seen in the previous example, any function that accepts a callback actually accepts any callable. So you can pass either a lambda, either a function, or either a functor. Okay, so now we close this folder, we open a new one. We will talk about context manager. So what is a context manager? So this is a class that exposes two methods, enter and exit. So you often use a context manager without knowing this. For example, when you open a file, you use the with statement, and actually this is a context manager. Whenever you use the with statement, actually you use a context manager. Some context manager are provided by Python, but you can define your own context manager. So here, for example, I want to define a context manager that will measure the time elapsed. So I will call this functor catch time. And so when I will enter in the with statement, it will traverse the enter method. And when I will exit the with statement, I will traverse the exit statement. So here, what do we do? When we enter in the catch time context manager, we save the current time. When we exit the context manager, we remeasure the time. We subtract the time that we have saved when we entered in the context manager. We do the difference, and so we get the time elapsed. Yes?
Is T accessible within the with block or only after?
So it's when you exit the with statement. So this is when you exit the block.
So T itself is not accessible inside, or is it accessible
inside? It's accessible inside. Because, for example, an example is when you open a file, you have with open blah 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 as f, and you use f inside. Okay. Okay. So now new unrelated notion, decorators. So the decorators are everything. Whenever you see an arrobas inside Python code, this is a decorator. So you have some decorators that are shipped with the Python language. So for example, arrobas properties, arrobas static method, arrobas class method. But you can define your own decorators, and actually some Python modules define some new decorators. And so why the decorators are useful? This is because this is a way to enrich an existing function, method, class method, static method, what you want, without modifying the existing code. So this is quite convenient, and often it leads to elegant code. So personally, I rarely define my own decorators, but sometimes it's useful. And as we will see, the functools module will define some decorators. So let's take an example of decorator. And you will understand why I talk about decorator. This is because functool provides some utility to define correctly your decorators. So here, for example, I want to measure the time elapsed inside the function f whenever I traverse it. So this is not related to the implementation of f. I just want to decorate this function to measure the time that is elapsed. So this is what is written here. So now the question is, okay, I want to add arrobas chrono before the definition of the function. What should I write to define my decorator? So decorator is a function. So I define a def chrono that takes a function in parameter. So this function actually is the function that will be decorated. And then inside, I will write what I want to do. And so what do I do? So here I measure the time when I enter. I call my function. So here, thanks to the star args and the star cowargs, I can forward all the parameters that are specifically related to f, so x and y typically. Then I print the time, and then I return the value that has been computed by f. And so by doing so, basically it measures the times, calls f, save the results, remeasure the time, print the difference, return the value of f. Okay, so now you can unify those two notions, so context manager and decorators. And typically you could use the context lib module provided by Python to do so. So here, this is what I will do to save time. So this is exactly the same example. The only difference is I use context lib to define my context manager. So here, so this is what is written here. So the writing is slightly different, but the idea is roughly the same. I won't enter too much in the detail. If you want more details, you can look at this thread on Stack Overflow that will explain you how it works. Okay. So now we have ended the introduction. We enter in the topic of today. So the functools module. So sorry, there is a typo, say utilities. So the functools modules provides several utilities to use caching, object comparison, typically when you want to sort some elements, partial calls. So I will explain what is it. Reduce. So basically, this is when you want to use an operator across an iterable. So for example, you want to transform the addition to a sum over an iterable. Type-based dispatching. So this is something that doesn't exist in the Python because there is no notion of polymorphism natively in Python. But here, thanks to type-based dispatching, you can more or less do so. And wrappers. So this is a way to write correctly decorators. So let's start with the caching. So first, why caching? So the perfect example of caching is when you want to do dynamic programming. So for example, I guess that most of you know the Levenstein distance. And so if you just write a recursive call, it will take ages because you will recompute many times the same thing. So the idea will be to save the intermediate results so that you compute them only once. If you don't know what is a Levenstein distance, you could think about the Dijkstra algorithm. This could be also done using dynamic programming. So this is several examples. Another example when you want to use caching is when some functions are slow. Typically, when you have I/O accesses, typically network calls. So in all those situations, you want to enable a cache. So you could obviously define your own cache, but it will be cumbersome. And so functools will help you to easily define a cache, which is thread safe and virtually of infinite size. So you have the normal cache, say, which is virtually of infinite size. So this will be the arrobas cache decorator, and you have also a LRU cache, which is of fixed size that you could also use. So let's explain what would happen if you don't use caching. So, for example, if I want to program, if I want to compute Fibonacci terms without using caching, so just a recursive call, I would write something like this. It will take, as you can see, a long time, and this is only the term 35. So it's already slow with a modern computer. Now, if I save the intermediate results, so using the annotation arrobas cache, sorry, the decorator arrobas cache, then it will enable implicitly with fib a way to memorize the intermediate terms that are computed during the computation. And so you can see that this is significantly faster. Before it was about 1 second. Here we are significantly faster. Yes.
I remember that there used to be a function named LRU cache. Is it just a renaming of this function, or does it do something different?
So this is what I said just earlier. So arrobas cache is a cache of infinite size. LRU cache is a cache of fixed predefined size, and then you define you implicitly define the policy of the cache. The last recent used key is dropped when the cache is full.
Okay, and by chance, do you know if it works well with class methods? Because I remember that when I tried to use LRU cache, I had some problems because there was in fact one instance of the cache for the whole class and not for every object of this class.
Yes. No, yes, so it works. So if this is for method, there is a specific decorator.
Okay.
So there is arrobas cache. So sorry. No, this is arrobas cache and arrobas LRU cache for normal method. And you have 2 other decorators for static methods and class methods. So first of all, you have to use the right decorator.
Okay.
And normally it works well.
Okay.
From my experiment, it works well.
Okay. It's based just off the parameters, right? If the parameters are the same, it uses the cache values. It doesn't have a context if there are side effects here.
So of course, the parameter enters in play in the key of your cache. So you will save fib with parameter 0, with parameter 1, with parameter 2, and for all those values, you will have a cache entry.
Yeah, it doesn't check, for example, if you're in a class that other fields in your class haven't changed.
No, if you face this situation, it will hit the cache and return what is in the cache. There are ways to clear the cache because actually it injects __dict __ variable where the cache entries are saved, and so it's up to you then to pimp your cache if you have something weird to do. I would recommend to rather use the cache when you know that the result is absolute, like for a Fibonacci sequence. But if the time allow, I will show you later in the end how you could clear the cache.
There are no methods provided to invalidate the cache.
In my knowledge, no. So now LRU cache. So this is what I just explained. So this is just a finite cache where you drop the oldest, the last recent used entry if the cache is full. Note that if the size of the cache is set to none, this is exactly as if you would use directly arrobas cache. So now for the properties, you have another decorator, which is arrobas cached property. So it replaces the normal decorator arrobas property. So here, for example, so sorry, the name are swapped because I was a bit tired when I wrote the slide. So here, this is rather the it's correctly written. So here, this is the fast property. Why? Because self.x is very quick. This is just reading an attribute, so it's fast. So cache is not required here. We won't spend energy to enable a cache here. Here, I will slow down this function just to demonstrate that the cache is effective. So assume, for example, this is a network call or something like this. So the first time, of course, I will pay this slip. But the next time, hopefully, I will hit the cache and directly return the cached value. So here, for example, I call my slow property. The first time, of course, it takes about 1 second. This is due to this slip. But the second time, as my slow property has been cached, it hits the cache, and so this is also almost instantaneous. Okay.
So
sorry.
The cached property must not change the state of the class.
Yes. So if, for example, so this was the question of Remy. If you alter self.x, you have to clear your cache because otherwise you will hit the cached value, which is obsolete. But you can but actually you can clear your cache. So here, if you want to clear your cache, it would be something like self.__dict bracket double quote slow properties double quote close the bracket, and so you delete this and you're fine. You have cleared the cache of your slow properties. So this is possible to clear your cache, and actually, yes, you have to clear your cache if it doesn't reflect the right state of your object. So now, new folder, we close the cache, we start a new folder, so the CMP2K. So if you remember, sorted takes callback, which is key. And key is not the order, this is rather a way to extract something that you will use to order your tuples, for example. But now assume that you are working in networking, you are implementing the BGP decision process, which is very complicated. So here, this is a simplified version. So you have to compare the first element. You have then to get the AS path, get the length. So it's very complicated. And so you have wasted hours to write your decision process. So you have a relation order that says, yes, this one is before or equal or greater than these two. So it will return either -1, either 0, or either 1. And now you can't directly pass this function as a callback because actually this is not extracting a specific value or crafting a specific value of your distance that you can directly sort. And so this is where CMP2K will enter in play. It will help you to transform this distance to a key callback that is compatible with sorted. So let's take an example. So here, for example, I will take a set of distance instances. So I have defined some instances, and here, as you can see, by using CMP2K, I can use either the BGP decision process that I have defined in the previous slide, or something else. So here, for example, this would be using. So here, this is by directly using a function. So this function. So I can pass my function as a CMP2K callback, which is itself a callback of sorted. But usually, you would like to define a kind of LT operator that allows to directly compare BGP distance. So here you can implement this one lower than these two. And if you want to plug your callback onto this operator, so you can do so. You will just pass the pointer to this method, to this operator, and it will enter in the right method. Okay. So now total ordering. So we have defined lower than, but what if we want to define lower or equal, greater than, greater or equal, etc., etc. So this is where the decorator total ordering will enter in play. Basically, it will take advantage of the existing operator to craft the missing ones. So it will save you a lot of code. And so this is exactly what we do here. So we have only defined lower than and equal, but it's enough for total ordering to derive lower or equal, greater or equal, etc., etc. Okay, so now new folder, partial calls. So the problem that you can face sometimes is your function doesn't fit the prototype that is expected as a callback. Because, for example, your function is more generic and accepts more parameters. And so you would like, so a typical example is this one. For example, you want to define a function that converts a string written in binary to the corresponding integer value. So what you could write is this. So you call the int method, you say this is base2, and so it will process the string and return what you want. So here, actually, I should have written a string, but whatever, it doesn't matter. And here you can do the same using partial. So it will exactly do the same. You will use partial. It will call the function int because int is a function. It's important to mention. So this is what you can observe here. And here I mentioned that the parameter base must be set to 2. And so what does it mean? It means that implicitly now the from binary function has exactly this signature. It only takes an integer. There is no notion of base. And so you can directly call from binary. And as you can see, it returns exactly the same value. So we now know how to use partial method. We might wonder how it works for methods. And so for methods, you have to be careful. You have to use arrobas partial method. Okay. So just for your information, when you craft partial object, so when you call the partial function, actually it doesn't return a function. It returns a partial object that wraps the function with the default keyword and argument. And so if you want, you can inspect the partial object to see what is a wrapped function, what are the wrapped args, and what are the wrapped keywords. So the args correspond to star args in Python, and the keywords correspond to star skywords. Okay, so now we have seen the partial. So let's see the partial methods. It's for methods, class methods, and static methods. So to be honest, I don't use it very often. So here, for example, we define a from bin partial method. So it will behave exactly as if I would define def from bin as the method of my class int. And this is a partial method that will call the class method from str using base equal to. So this is quite useful if you want to define some shorthands in your class.
But this is only for class method, so not for
methods, class method, and static methods. This is the same syntax. So here I use the class method, but it could work also with a normal method. Yes, Rémi?
One additional use for partial is on constructors. Sometimes instead of having a derived class where you're just changing the parameters, if you want to pre-provide some parameters for a class, you can just do partial on the constructor, on the init method.
Yes. Actually, I don't. On my personal side, I rather define one constructor, which is the default constructor, and then if I want, say, new constructor, I define some class methods that I prefix by from something. So, for example, from string, from config file, from what you want, and it will call in the end the init constructor. So this is rather this way.
It works if you're inside a class. If you're using a provided class that you can't change, and you want to specialize it, you can either derive it, or you can partial the constructor if that's all you're doing. There are use cases for that. But...
Okay. So thank you for the remark. So now, a new unrelated folder. So sorry, there is not a long story because this is the module provides unrelated functions. So reduce. Reduce for the recall allows to transform a binary operator to an operator over an iterable. So for example, you have the addition and you want to derive the sum. So of course the sum natively exists in Python, but this is just to show you a simple example. So here, for example, so if you use reduce and you pass as a callback the sum, the binary operation of the sum, then you can apply in a pairwise manner from the left to the right the addition. So you will compute in plus 1 plus 3, which is equal to 4, then 4 plus 5, which is equal to 9, etc., until getting the sum. Okay. So dispatching.
Actually, just a question mark.
Yes.
Is there a way to specify what happens if each variable happens to be empty?
It's a good question. I think it's. I didn't try, to be honest. Okay. Just try. You will see. In the worst case, you just do a try except and that's all. But I hope that this is implemented in the reduce, but I'm not sure.
There's a default value you can provide to reduce.
Probably, yes.
Normally there's an implicit comma 0 there, which is what you do.
Yes. The
value that's returned.
Yes. Yes, it would be logical because, of course, when you compute the sum of an empty list, for example, you would like to return 0. So yes.
I think by default it's 0.
Yeah, and sometimes you don't want to return 0 actually.
If you're doing a product, you want to specify comma 1 as your base value.
Okay, so the dispatching. So as I said earlier, so contrary to Java or C++, you have no notion of function overloading or polymorphism, call it as you like, which allows to call the appropriate method depending on the parameters of the method. But actually, there is a way to address this problem in Python, and this is by using dispatching. And so the dispatching is a way to inspect the type of each parameter and decide which specialized method that you will call to process those arguments. And so to do so, we will define a dispatcher using the decorator @single dispatch, and then we will register some specific processing using @star register, where star is the name of the dispatcher. So it's a bit abstract, so let's see an example. So here we want to define a dispatcher. So let me recall. Yeah, so the goal is, for example, to yes. So the goal is to write a dispatcher that will enable debugging when you call a function in some situation. So here, for example, so at this point, it seems useless. What is the purpose of @single dispatch? This is because for the moment it's useless because we have registered. We didn't have registered anything. So the goal is just to define what we would do when we handle a specific value. So if I call foo my value without verbose, okay, it doesn't print the debug message. If I pass through, it prints the debug message. Okay. So now let's see what happens when we start to register something. So here, for example, I want to register. I want to register foo when calling some functions. So I will start from the bottom because it will be more clear. So here I have defined several arguments and integers that will be handled using a specific processing, a list, and a float numbers. And then I will call the foo method either using the verbose mode or without using the verbose mode. And as you can see, so if I enable the verbose mode, as I have registered specifically for integers here or list a specific treatment, it will enter in this specific treatment. And so this is why we can see those debug message. And for the last type, which is a float that has not been registered, it will use the dispatcher that we have defined just before. So this one. And so this is why here you can see verbose generic. So basically, what you have to understand is when you define the dispatcher, it defines the baseline behavior, and then you can specify specific behavior using register. Yes?
2 questions. When you register a function, do you need to specify the default arguments or not? Is your def they're already in the original call?
I think it doesn't matter.
And do you have a way of filtering, for example, on I want this called only if verbose equals true?
I don't think so, because this is purely based on the type of arg. So here, the idea is because verbose precisely is the mechanism that decides what should do the dispatcher. So it's not a normal argument if you want. So I would answer no to this question. And so you could obviously use dispatching for your own type. So for example, the BGP distance that we have defined a little bit earlier. And so it's possible, once again, to register a specific callback when you pass a BGP distance to the function foo.
And tricky question, do you know if you can use the advanced type hints like list of int, list of string, stuff like that? With the from the type.
Yes, so you think about the typing module that enables, for example, a list, a bracket int, or something like this. I didn't try. I'm not sure it works because actually, and you have to pay attention because depending on the version of Python, the dispatching more or less works depending on the types. So I wouldn't try it. And if you have such needs, I would recommend you maybe to consider a more powerful language. For example, C++.
In your examples,
Sure.
the type of the first argument is different. But can we have the same first argument and then the different type in the second or third argument? Will it work?
So here we are just registering a new behavior specifically for an object type. Before it was for list, etc., etc.
You can have several arguments.
Ah.
Three on the first two.
Yes, I get your question. I don't know. I didn't try, to be honest. I think it should work, but try and you will tell me.
In the original definition of foo, the type of arg is what?
Yes, this is because we have a single argument. So if I understand correctly the question of Sebastian, this is what if foo has several arguments, could we dispatch across several arguments? I guess the answer is yes, but I didn't try, so try and you will tell me. It's a good exercise.
Because sometimes the signature of the function is simply the number of arguments that is different. So could we trigger different code based on the number of arguments?
I don't know.
I will try.
I don't know. Try.
I will try and tell you in a few minutes.
Yeah, sorry, I didn't try. So I will try to move on because we have the time is running. So now the single dispatch method. So what is it? So roughly the idea is the same, but instead of dispatching on top of a function, you want to dispatch on top of a method. So here, my default behavior, so my dispatcher will be this one. So I want to raise an exception. For example, this is not supported. And here, I want my negator to support the negation of an int, so it will return the opposite number, or the negation of a Boolean, it will return the not of this Boolean. And so here, so I have registered my two class methods according to this class method dispatcher. I call my two methods using, so here I will call it with 7 and false, so it will enter here and here. And as you can see, I am able to negate those two values. So it works. So you can use this for method, class method, static method, and abstract method. So abstract method, there is a dedicated module in Python which is called ABC. If you want more detail about abstract method, there will be probably another Python tutorial about it.
Maybe there has already.
Or we already have it. Okay.
Not sure.
Okay. So the decorators. So it's quite easy to write a decorator, but often when you will write your decorator, you will write a bad decorator. So here, this is an example of bad decorator. And why this decorator is bad? This is because it will overwrite the docstring of f. So here, for example, so as you know, you can inspect the docstring of a function by calling f.__doc. So here, I would expect to see the docstring of f, so I should see f's docstring. Unfortunately, I see something else, and actually this is the docstring of the wrapper. So I'm quite unhappy. This means that the __doc is not pointing to the right docstring. So how to address this problem? So the easiest way to do so is to use the arrobas wraps decorators, which allows you to define a good decorator. You use this syntax, and actually you will get in the end the right string. So this is mostly syntax, so I won't enter in the detail because, to be honest, you have to have an example under the eyes when you use these kind of things. Okay, so I think we have time to cover the operator module. Actually, it's quite quick. So the operator modules is a way to expose any standard Python operator as a function, the addition, the subtraction, etc., etc. And so this is very powerful because actually now you can use any Python operator as a callback. This is the spirit of the module. So for example, if you want to use the addition, you can use the addition like this, using plus, like always. But if at some point you require a function that implements the addition, then you can use add or underscore add. So this is two equivalent syntax. Both names are strictly equivalent, and both syntax are supported. So why is there? Do we have the underscore syntax? This is because as you know, when you overload an operator inside a class, this is often done using a callback method underscore lt underscore or underscore add underscore. So this is always the syntax in Python. And so in operator, you have for most operator the both possible naming. And so the goal of the following slide is just to show you the naming and the logical of those namings. So of course you could use add or underscore add in your reduce function to compute a sum. Yes?
Out of curiosity, is this more efficient than defining a lambda?
It's a good question, but I would answer yes, because in the worst case they use a lambda. So it's in the worst case this is equivalent. Actually, if I have time, I will show you an example. For example, assume that you want, I don't know if you heard about Cartesian genetic programming. This is a kind of, say, neural network where neuron, instead of implementing a sigmoid, are implementing an arbitrary function. For example, addition, multiplication, etc., etc. And in Cartesian genetic programming, you identify the operator labeling node using an integer. So for example, 1 will be the addition, 2 will be the multiplication, etc., etc. So you will have a dictionary that maps each of those indexes with the appropriate operator. And when you will run your neural network, you will process forward your value across your network by calling the appropriate operators. And so this is a convenient way to pass operators to a structure that is more complicated. Sorry. Okay. Another example, more simpler than Cartesian genetic programming, is abstract syntax tree. So you have parsed kind of operation, and now you want to execute this operation. You want to call the appropriate operators, then the operator module will be useful. So here, this is just to recall. So this is just to illustrate what I explained earlier. So by default, so this is unrelated to the operator module. When you want to overload an operator in a class, you have some predefined expected name, underscore add underscore, for example, for the addition, to specify what should be done when you add this, when you sum two complex. So this is what is done here, and so this naming is closely related to the naming done in the operator. So now let's see the naming. So for the comparison operator, so lower than, lower or equal, greater than, greater or equal, inequality. The main purpose of the slide is just to give you the names because this is quite obvious. And as you can see, the class callback is directly reflecting this naming. If you dislike the underscore names, you could use those one. This is strictly equivalent. Then you have the algebraic operators. So absolute value, positive value, negative value. So this is the positive value and the negative value are unary operators. So this is why this is not a standard addition or a standard subtraction. Then you have the binary addition, the binary subtraction, the multiplication, the matrix multiplication, the division, the Euclidean division, the modulo, and the power. Yes.
You wrote 2 slides back that for add, for example, there was a trailing underscore.
Right.
This is not the case here because.
Yeah, there are some exceptions. Sometimes it happens.
For n.
Oh,
sorry, it was for n, not for add. My bad.
Yeah, so it was, so indeed, you will have a collision, for example, for Boolean operator. This is what we will see later. And so this is why you will have a different naming. So I will come to this a little bit later. So then you have the in-place operator that are more efficient than, so for example, instead of computing x equal x plus 1, you will rather write x plus equal 1. And so, of course, once again, you can overload the in-place operators. So this is quite natural. So in terms of naming for the callback operator or the function operator, you just add a I in front of the name of the operator. Then you have the identity operator, so which implement the keyword is or is not, or when you run if something which is not a Boolean implicitly, you cast it as a Boolean. So there are operators for all this stuff that are here. Then you have the bitwise operator if you do low-level programming. So for example, packet manipulation or this kind of stuff. So the bitwise not, the bitwise and, the bitwise or, the bitwise exclusive or, the left shift, the right shift, and of course, the in-place bitwise operators. So maybe more useful for most of you, the iterable operator that implements the bracket behavior. So once again, we can overload all those operators. So allowing to implement the indexing when you're using an iterable, the concatenation, the statement in that tests whether an object is contains. So you have to be careful because for in the keyword is reversed. So this is contains, this is not in. So semantically speaking, this is the converse. The length int, which allows to get faster the length of an iterable, which without iterating over the whole iterable. The counters, which is useless, maybe. Index of, which seems also useless. So I don't know why it exists, but it exists. Yes?
So these operators are used for callbacks, and you say contains is flipped. So contains needs to take first the container and then the. Okay.
Yes. So you have the slicing. So this is, so for example, in NumPy, when you write array bracket I the semicolon j, you are using slicing. So you can once again define those operators. So the callback operators, or once again use the operator module to get the corresponding function. The call method that we have seen for the caller and for the partial objects. And so the operator module also provides some convenient way to define some functors. So for example, item getter. So this is exactly the item getter that I have defined at the very beginning of the presentation, but actually it natively exists in the operator module. So this is just to show you. So here, for example, so this item getter is more generic because it can extract several elements from the input iterable. So here, for example, I will extract the element 0, 3, and 2 from the input iterable. So here S. And so as you can see, you will extract A, D, and C from this string. Okay. So it's quite similar, but you have an attribute getter that extract, for example, so if I reuse my complex class that I defined earlier, that extracts the real or the imaginary part of the complex number. So actually, it will inspect z1.a and z1.b. And that's all. And so if you want more detail, you can look at the functools documentation, the operator documentation. Thank you for Jupyter Lab for existing. Thank you for Rise for existing. And if you have questions, they are welcome.
Thank you. I have an information and a question. So the information that I had a look at the dispatch thing. So apparently the single in single dispatch means that you can dispatch only on a single argument, which is the first one. And in fact, for multiple dispatch, there exists packages, but they are less standard than functors, so maybe also less reliable, less prone to long-term maintenance and so on.
So it means it's dispatching on the first parameter and not just dispatching to the first matching function.
No, dispatching based on the type of the first parameter. Yeah. Okay. So that was the information. And my question is philosophical. For example, when so typically for aggregator, for example, which we typically you would use in a sorting operation as a key, for example.
Yes, for example, on the real part. Yes.
I wonder. So to use aggregator, so you need the import statement, and then you will put aggregator somewhere and so on. Whereas you can also say simply key is equal to lambda that to x associates with x of 1. And I often wonder whether it's really worth using aggregator because it's less clear. For example, if I have a colleague that are not used to Python and that codes in Python once in a while, for me I should think that it's clearer just use to
the lambda.
To use the basics of the programming language rather than syntactic sugar like some things that are in the functools module.
So I definitely agree with you. I never use aggregator exactly for the same reasons. I used at some point item getter, but it's for very specific rare use case, and it's not clear that it's better than lambda. Even in the case I use
performance, it should be exactly the same.
Yeah, actually, this is a PhD student who makes me discover item getter that I never used before because I was happy with lambdas. And aggregator, I discovered it when preparing this presentation because I never get this need. So.
In fact, apart from some specific things that you mentioned, like I don't know which one, but in fact, for several of the things in the functools modules, I had the same kind of questions because very often that's stuff that can be written just with a very small lambda.
Yeah. So for partial, honestly, partial I use it quite often.
Yeah.
All the caching stuff is very useful.
Yeah, sure.
Honestly.
The caching stuff you cannot do it with just one line.
And then the dispatching, honestly, it's not. It's rare because when you start programming in Python, you know that there is no polymorphism, so you start to define your classes in a different way. But the caveat is often you get a lot of methods, and I guess that here the goal is to get a more elegant design, and then you would require a dispatcher in this case. But as you said, there are limitations with the dispatching module, so you can't do everything you want. Depending on the version of Python, the dispatching supports more or less kind of basic types. So if you use a recent version, there is no problem. But if you use old Python, it might not work. So to be honest, I wouldn't encourage you to use the dispatching, but the goal was rather to give you an overview of what exists, and then you decide if it's relevant or not.
One very stupid question on this slide. If you only specify one parameter for attribute getter, will it return a tuple with one value or just the value?
Just the value, if I'm correct.
It removes the tuple.
Yeah, actually, it crafts a tuple when there are several. Yeah.
Otherwise, it becomes very hard to use. The second thing was a comment concerning caches. When you use add cache, it actually injects a clear cache function on the method for the function. In the method. Yeah, on the method.
On the method.
You can call method.clearCache at any time to clear the cache.
Method.clearCache. Yes, there is something. Yes, there is a syntax like this.
However, it clears the whole cache. You can't invalidate one cached value. But there is a utility to it when you know that if you change something in your class, the whole caches are validated.
Yes. So yes, indeed. So it depends. Yes, if you want to clear the whole cache, you would do what I explained earlier. So you could directly clear the entire cache, but you could also maybe use.
If you want to be more fine-grained,
yes.
then you have to go and do it by hand.
Yeah. Okay. Is there any other question?
Can you change the decorator when you refine the function several times? Different tools?
Can you change?
Yes.
I'm not sure to handle the
You can
question.
have multiple decorators on a same function.
Yes, you can use multiple decorators on top of the same function or method or class method. Yes. So you can have columns of arrow bars. Yes, it's possible. But here, pay attention because most of the decorators that I presented replace the existing decorator. So, for example, arrow bars property will become arrow bars cached property. You won't write arrow bars properties, enter arrow bars cached properties, then your method. You will only write arrow bars cached properties.
The last thing that about decorators is they can have parameters, but then defining them is ugly. You can have decorators with a parameter.
Yes.
But then the definition of that decorator is even more ugly because you have an extra wrapping function.
Yes. So the typical example is the LRU cache that takes as a parameter the maximum size. So yes, this is an example. You can also have an argument that parameterizes your decorator. It's possible. Yes.
Another question: when you for the dispatch, can you dispatch on the value?
No, it's type based. If you want to do this on the value, it's an if statement.
Okay. Apparently, it's based on the type, and from what I saw very quickly, you can do it. So that was one of my questions based on a list of int or a list of string. This you can do. From what I read quickly.
Yeah, so I've read something like this also, but I think it depends on your version of Python. To be honest.
Yes,
you have to use quite recent
do this at home.
Yes, yes, it's a bit dangerous in my opinion.
Yeah,
and
they know the risk.
Actually, I'm not even sure that this is quite useful because in practice, I mean.
Just to mimic template metaphor.
Exactly. But we are not yet at the level of C++. we don't have recursive templates, for example.
I have a quick background question on lambdas that you feel free not to answer. When you declare a lambda, is it declared as a function only one, or is it declared every time you run the code there?
I think this is just so it depends where you declare your lambda actually. Is it as a variable of a function or a method? Then yes, you will like any normal variable. Yes, I guess.
I seem to recall there's a question about lambdas behaving differently than functions compared to scope, that they don't like inherit the scope. If that means anything.
So in terms of scope, it's quite complicated because in C++, indeed, you can define what is the scope of the lambda. Is it just the local variable or more, say, or just so in Python, the lambda function sees the global variables, the local variables, and all what you could see where you use it, basically.
Okay, so it grabs the scope.
Yeah, you have the same scopes as if you would code inside this scope.
So if you have a lambda function inside a function that uses a variable inside that function, and you return the lambda from your function, you can still access that variable.
Honestly, I wouldn't do so.
Sorry, this is basic 101 JavaScript behavior.
No, but you know that I hate JavaScript. You will try and you will tell me, but honestly, I'm not sure it's a good idea to do so. But you could try because sometimes you have some limitation. What I have observed in the past is sometimes nasty things happens with the lambda function scope. So I wouldn't try so. I think that in many cases you might have problems. And actually, remember that you can define a function inside another function. So for example, don't think that because you are inside a function, you have to use a lambda function. No, if the callback that you want to define locally to your function is quite complicated, just define a new function inside this existing function.
So maybe let's thank Marco again.
Thank you.
And let's have pizzas.
Thank you.
Merci.
Is there any question on the bridge? No? Okay, so goodbye. Bye-bye.
Yes, you can return lambdas from functions and they grab the scope. It's ugly as hell.